Good afternoon, everyone. Myself, Alan, an associate software engineer working at Red Hat. Here, along with me is Suraj, who is working as a product engineer at Strollby. So, today we are here to talk about something which most of us have experienced. So, how many of you here have used Pandas? Okay, quite a few. So, imagine you are working with Pandas and suddenly your notebook starts freezing, or there's a sudden memory spike, or the pipelines which used to run in seconds, it's taking minutes to complete. So today we are to talk about why all these things happens and a few changes that which we can take to make our pandas dramatically faster. We don't need a Spark, we don't need a cluster. All we need is a better pandas habit. So these are the contents which we will cover today. Um, so first we'll understand why our pandas get slow, and we look into some of the common mistakes that our developers make, and yes, we'll look into how to fix them. Also, we'll see some of the performance diagnostic measures and when it makes sense to use alternatives like DuckDB or Polars. So this is not a theory; these are practical tricks that you can apply tomorrow. So why this talk? Pandas is everywhere. So it basically powers data pipelines and analytics dashboards or ML workflows. So imagine you are a developer, and so at first you can see Pandas starts working beautifully. So unless data sets grows, so there's a sudden spike in memory, or it becomes slow and unpredictable. And the interesting fact is that most of these issues happen because of a common mistake. So the core of the talk is simple. It is to make your pandas fast without abandoning them. So who this talk is for? So this talk is pretty broad to a large number of audience. So whether you are a backend engineer working with data pipelines, or an ML engineer working with data processing, or you are a data engineer working with ETL pipelines, or just you are processing data sets which is from ranges from medium to large scale, you may sooner or later run into these performance issues. So before moving on into this slide, let's refresh our basics on pandas very quickly. So pandas is basically a third-party Python library which is used for data processing and manipulation. And so here I've created a Jupyter notebook. So I've created a virtual environment, and I've installed pandas. So since it's a third-party library, we have to install it via pip install pandas. So to use it, I've imported pandas as PD. So one thing is, when we feed data to pandas, pandas automatically converts data to data frames. So what are data frames? Data frames are basically table-like data structures which stores data in the form of rows and columns. So why do we need data frames? So the data frames are usually stored in our memory. So we have quick access to these data frames, and so since we have quick access, manipulation is data processing and manipulation is very easy. So here I've provided a two-dimensional array with three columns and two rows as the input to pandas, and I've labeled columns as ABC. So just to see the data frame, we can use the head method. As you can see, we have three columns, two rows, and pandas have automatically created indices for each of the rows. Now let's say if you want to see last rows of your data frame, you could use the tail method, and I could pass in an integer which denotes how many rows from the last you have to see. Since I just want to see the last row only, I've passed one here. So as you can see, you only have the last row printed here. Now let's say I want to see more info on a data frame, I could use the info method. It provides all the columns there, if there are any null values, and what are the data types associated with each column. So every information is given here. And let's say if you want to see the shape of a data frame, so we have provided a 2 by 3 matrix, like two rows and three columns. So df.shape provides these info. And also we can read external data from files using pandas. So we can read CSV files, Excel files, etc. So what are CSV files? CSV files are basically comma separated files which contains particular columns and their corresponding values. So here I have three values, three columns: day, coffee type, and unit sold. Basically, it says on Monday you have sold 25 units of coffee type espresso. That's it. So to read the CSV files, Pandas provide read CSV method. So I have read coffee. So I've named it coffee data frame. To view the contents, use the head method. And let's say if you want to list the unique values of a particular column, so you can use the unique method. So just to use it, you can use the coffee df variable, and within square notation, you have to provide the column name for which you have to see the unique values. So as you can see, coffee types are only just two coffee types: espresso and latte. And let's say if you don't want to see all the rows, you just need to see like maybe like a first three rows. So you can use the log method. Log method, you just have to pass in the indices of the rows. Let's say I want to start from indexing pandas is 0 based. So if I want to see the first three, I'll have to start from 0 slice 2. So I've given 0 to 2. And let's say if you don't want to read the entire columns, you can pass in the name of the column to which you want to read. So I just want to read the unit sold column. So it's, as you can see, I've only read that particular column and the first three rows. And ilog also has a similar functionality. Expect the fact that if you don't want to pass column names to that to the ilog, you can pass in the column index. So instead of passing column name, you should just pass the column index. That's the difference. So it also brings the first three rows with the column unit sold only. Now let's say if you want to sort your data frames, you can use the sort values method. So you could just pass in on what column basis you can sort. So I just want to sort my rows based on unit sold column, and I want to sort it in descending order. So now you can see the higher values for units sold are coming at the top. So it's sorted in descending order. Now let's say I want to filter some data. So you can use the square bracket notation with the column names provided. Let's say I want to list all columns, all the rows with units sold values greater than 25, and I want to add a conditional statement. So I want to combine two conditions. So I can use the percentage operator, and I want all units sold should be less than 40 units. So these two combinations, so when we are evaluating these conditions, we in turn get raw numbers, and when we pass raw numbers to log method, we'll be able to fetch those particular rows with that indices, right? So as you can see here, we have all rows with units sold whose value is greater than 30, greater than 25, and less than 40. And similarly, if you want to add a particular column, say, let's say I want to add a new particular column to our data set. So just use the square notation and pass in the column name here. And I've created a column name type with all the values latte. Now, just to see the new data frame, you could use a head method. And as you can see, like I have added a type column with all values latte. Now, let's say if I want to drop my column, I could use the drop method. I should pass in which column I should drop. So I want to drop the type column. And there's an extra parameter called in place equal to true. So if we don't pass in place equal to true, it doesn't modify the actual contents in memory. So to basically modify contents in memory and delete that particular column, we should pass this parameter in place with value true. And so after deleting, you can see the type is removed from our data frame. So thanks for listening. That was a quick, refresher to pandas. I know like everyone is familiar with pandas. So why pandas get slow? So this slide is the basic core of our talk. Pandas is fast when you use it like NumPy, but it's slow when you use it like Python. So what does that mean? It basically compares vectorization versus row by row looping. I know this doesn't make sense right now, but we'll cover this in detail in the coming slides. So, so over time period, we have analyzed a few common patterns in slow pandas code. So some of the common or offenders are, using Python loops over rows, misuse of apply function, inefficient joins, wrong data types, hidden copies, and loading too much data. So like the good thing here is that we do have a fix to all of the above problems that we have mentioned. So we'll be covering it in the coming slides. So stop looping. So this is one of the most common mistakes we make. And it's quite natural. As Python developers, we tend to use loops, but loops are not a thing for pandas. So it's a wrong tool for pandas. The loop anti-pattern. I'll start with an example. Let's say I have a large data set with like maybe like 20,000 rows, and just it has just two columns only. So one column contains total price price of a commodity, and other column contains the total units sold of that particular commodity. Now let's say I want to add a third column which calculates the total price of that particular commodity. To find the total price, we need to multiply price of one commodity into total quantity of that commodity sold, right? So I can do this in two ways. So first one is, as discussed here, it's the iterative way. What I do is I go from uh, all the way from top to bottom and start multiplying. For each row, I'll start multiplying price into quantity of that particular commodity sold. So this might seem simple and convenient, but it's like a really inefficient method because of three main reasons. So by looping in Python becomes very inefficient as data set grows. It is really slow. Second thing is, so for every iteration, I have to access two columns, mainly the price and quantity. So there's an extra overhead on that. And the third thing is the scalar operation which is being done. So what are we doing here? We are multiplying two columns, right? It's not done in bulk. So for every row, I have to calculate this. So it becomes a time-consuming process. And this is a second approach. So vectorization. So under vectorization, we use pandas. So in pandas, instead of looping over the entire rows, does this entire scalar multiplication on my entire array. So and internally, it uses low-level language like C for its implementation. So instead of Python looping over the entire row, millions of row, no, at a slow pace, we are doing it at a much lower scale and at a good. It's like 100x performance benefits. Like if we use vectorization instead of looping over rows. And apply method. So I think if those who have used apply, we use apply methods for either filtering or let's say I want to manipulate my data, and if I use parameter axis equal to 1, let's say I'm doing my operations along the row axis. We are so what we do under the hood is similar to Python's row by row execution only. So it's really inefficient. So the rule of thumb is simple. Let's say if I have something which can be vectorized, never use apply. And next is fixing your data types. This is one of the problems that we have mentioned earlier. So this will be discussed in detail by Suraj.
Thank you, guys. So, okay. So this is about the data types that we use inside Pandas. So suppose if you have a data source like CSV or Parquet files, and you are reading using Pandas, it can actually automatically detect which kind of data is inside the columns. Um, like the integers, the float 16, float 64, depends on the size that we have. The Boolean values are also possible to detect by the pandas, but sometimes when we are having complex data types like date, it's not going to detect. So it will be detected as, or the fallback as the object itself here. But suppose if you are having a large data set which has a lot of duplicates, what are we going to do? We have to do the computation for all the rows which are having the duplicates also. So it's kind of inefficient, right? When you are having large amount of data, it's very inefficient, right? So what can we do? We can do something known as categoricals, which is as this. We can give a function called as type to it, which actually does is that creates a hash map and gives which gives all the unique values in the columns inside the hash map and gives a unique ID for it, and backtracks it to the data frame that we have, the data frame Alan actually showed, right? So by using that, we are actually going to reduce the size. Like it actually happens in two ways. The first thing is that instead of storing the large data, say a large string, you are only going to store the small index that we have, right? Another thing is that it's going to be very faster on using the joins and all the cross-functional dependencies and all. We'll see how it actually does that, but just keep in mind that it actually keeps a hash map. In general terms, kind of a dictionary, right? So it actually reduces the memory up to 90% because of the reason that you don't have to redundantly store all the duplicated data. You can only store the singular small index values that created by the hash map. The another thing is the faster group by and join operations, because like it's very much easy to compare integers than comparing strings, right? So it actually gives, if you are actually using categorize, you can actually get a faster group by and join operations. We'll see what are join and group by operations in the later slides as well. So yep, that's it. Another important thing that we could do with this is actually downcasting, which means that suppose if you are having a column which are say very heavy, like say float 64, but you just don't need that much precision, what can you do? You can downcast it to say float 8, float 16, depends on your use case. So that's something that you do with this as well. So another thing that we are going to discuss is about copying. So like copying is the heart and soul of the data frame operations, because like whenever you are doing something, it's going to create a copy, or we need to save a copy of it by either means of cache or for the next steps as well. So suppose if I need to get the price greater than 100, this is the trivial way, right? This is the trivial way that we are going to do. But if you look closely, it actually creates a full-blown copy of the data frame every time we, enter this, the command. It is because that pandas is eagerly executing. So eagerly executing means that whenever it sees this command, it just executes as it is. Okay. We'll see that what are the better ways of doing it in the later slides. So another problem that creates the copy of entire data frame is this, which is called the operation chaining. So the first thing actually does the operation first and then moves to the next one, and it actually does the assignment as well. So this is also going to give a warning from the panda side for setting with copy warning. But is there any better way to do that? Yes, we can do that by using a mask. So this is called the Boolean masking, or a Boolean series. So this actually gives a Boolean series which actually matches with the log functions that we have, and matches with the corresponding rows that we have, and assigning into one. The interesting fact is that the log method actually changes the data in place rather than creating a copy, right? So that's one of the best way to do the operations on the raw ways. So now let's move on to the joins and group by. This is the most important part, because like if you are actually using it for data analysis and part, this is the heart and soul of it. So yeah. So in the case of joins, like how many of you have used SQL in any way, like Postgres, or I guess everybody knows, right? Yeah. So so joins are something when, in this case of data frames, when you have two data frames, you can join it. Even it can be same, can be different, but you can have a similar column from both sides. You can join it. So that's the naive definition of joins. Another is the group by. Like how many of you have used group by? It's kind of a rare. How many of you used group by? Yeah, it's kind of a rare thing. Um, so the thing is like it actually groups according to a row, the particular row value, and just gives a group in the naive terms. So suppose if you have some data frames like teachers and students. Okay, so a teacher can have multiple students, and a single student can have multiple teachers as well, right? So it's kind of a many-to-many relationship. So if you're not indexing it, if you're not using the categoricals also, like it's going to be a column scan for both the data frames, which is very inefficient, right? Um, so that's the something that we need to be looking out for the joins. So how can we optimize it? One of the things that we could do is again go for the categoricals, so that a hash map will be created and the matching would be done for the integral part. Another important thing is about sorting. We'll see how sorting improves, the merging. We'll see in the next slides. And of course, dropping unused columns, because like if it's not needed, you don't have to use it in computation, right? So yes, that's it. And the next is the group by. So like as I said, it's kind of it's kind of grouping rows according to a particular column value. For example, if it is city, it's actually going to group all the rows from the city column. And we are going to do the sum operation on the sales column, right? So this is what it actually does. So how to optimize it? We can use categorical for the city. Again, sorry. Again, it creates a hash map. So the grouping things would be much more easier for that. And if the data is sorted, it's going to be faster. Like how it's actually going to be faster? Let's think about it. So if you're not, let's say if it's not sorted, it's going to, Pandas internally is going to create a hash set to match between both data frames, right? But say if it is sorted, it's going to create a sorted set so that it's much more easier to look up. For example, if you have seen binary search, have you heard of binary search and all these things? Yes, it's a kind of basics for computer science students, I guess. So for that, like the operation is pretty similar to that as well. So like it can check after that particular point itself. So like if you are actually using sorting before merging, it's going to be much more efficient. So yep, that's how you can optimize the group by operations as well. So off to Alan.
So now let's discuss something that we often, like most of us often ignore. That's any guess? It's basically file formats. So I think most of us have used no CSV, like worked with CSV files. So we use the read CSV method. But let's say I have a large data set with like 500 columns, and I need to process this like 5 columns. So is it feasible, or is it required that I should load all the columns into memory? So that's one question. That's one thing that we have to think. So if I need 5 columns, I don't have to load the entire thing. So in read CSV, we have the property called use columns. So under that, we can specify what all columns are to be loaded into the memory, so that we don't load the entire thing into memory. So this is one thing that improves efficiency of a pandas code. Another thing is, so we have an option to specify data type for each column that we are loading in. So this significantly reduces the cost overhead, because if we are not specifying data type of each column, pandas has to go and find out from the values. So this is a int or this is float. So that also takes much of our time. So keep in mind, always use these two parameters, use columns, wherein we specify all the columns that we are to be loaded, and the data type property, wherein we specify data type of all our columns. And so is there any better file alternative or better file formats for CSVs? So first of all, why do we need alternative to CSV? Because CSVs usually store data in plain text format, and we don't have the ability to compress data. Also, CSVs does not store data type information of the data that we are loading. So, as you can see, it takes so much time to load a big data. It is slow and compute resource, because it has to identify the data type and all. So we needed something which can solve all these problems. So we have paraquets and feather. So what makes it unique? CSVs usually store data row by row. As I've shown you, like a coffee.csv file, it stores data row by row. But parakeets, they store data column by column. So they are loading only data, not the whole content. It's loading only what we require, right? And we have data compression too. Since the data is small because of compression, and we are loading only what we require, the data access is very fast in paraquet. So we have the two paraquet method in data frame. So we could convert our CSV files to paraquet format and then do our data frame operations. So before we try to optimize our code, we need to measure like whether we actually need optimization, right? Um, So there are two tools for optimizing or finding, whether comparing the methods we use. So first is percentage time it. Let's say if I want to find the average execution time of my code. So what this tool does it, so it runs a code n number of times and give the average execution time. Let's say, so as already mentioned, we compared two methods for calculating a third column, right? Vectorization and row by row looping. So um, we can, with this percentage time it method, we are able to know which method, that is vectorization or row by row iteration, does gives better performance. And there was one more. Let's say I'm working with large data sets. So large data sets tend to take a larger memory or a compute of a CPU of a computer resources. So to let's say I want to set up my infra and I want to know how much of memory I should allocate. You could use this info method. So from where I am able to know, okay, this data sets consume this much bytes of data memory. So keep these two tools handy. So as mentioned earlier, we took an example where we created a third column, total price, by multiplying price of one commodity into total quantity of commodities sold, right? So we did the benchmarking, like so we took a large data set with over 1 million rows, and I think size was approximately 95 MB, and we did this benchmarking in a 16 GB laptop. So the results were shocking. The loop version of that took around 12.5 seconds, whereas the same vectorized version, it took just 0.08 seconds. That is like 150x times greater. So the result might vary based on your hardware, but the common pattern observed is vectorized version always tend to overcome the looped versions. Um, so till now we have been discussing how what are the methods that we can adopt to optimize pandas. But in some cases, pandas is not enough. Uh, these are cases when our data is very large or our workflows becomes complex. So we needed some modern tools, like Polars or DuckDB or PyArrow, which can work along with pandas and improve its performance. So these tools are not replacements for pandas; they complement pandas. They work along with pandas to improve its performance. So what all features these tools bring in? First is parallel execution. So pandas basically runs code in a single core, so it's not that fast. Whereas these tools, they can run on multiple cores. So data processing occurs at a high speed rate. Then there is lazy loading. So pandas usually load the entire data into its data memory, but these tools, they do not load the entire data. They first make a data loading plan, then optimize the data loading plan. Then only it loads that optimized data into memory. So there is not much memory wastage there. And the third thing is, so tools like DuckDB, we can execute raw SQL on the data directly. So analytics is very faster with the help of DuckDB. So Suraj will give a detailed info on these. So Suraj.
So I've explained about the eager execution in the pandas, right? So it's directly opposite to it. It does lazy evaluation. So that way it's called Polars. So the thing that makes Polars great is because of its the way of the execution and how it's actually been built from the ground up. So in the case of Polars, they are actually built with Rust. The core part is actually written in Rust. Also, it's built for parallelism so that you could use all the cores inside your system for maximum computation efficiency. So yeah, another thing is that this is a kind of query pipeline that we have. So this is kind of chained operation that we see inside the pandas, but but since it is done in Polars, it's much more efficient because of the query planning and query execution. So another important thing is that, so you have heard that NumPy is the base for pandas, right? The internal representations are done as NumPy, but in the case of Polars, the representation is done as PyArrow. Apache PyArrow is the internal representation, which is a columnar format for Polar. so which makes the execution much more faster. And like if you have seen the operations inside the numpy, you can see that every time an operation is done, it creates a copy of it, and the operation is done on that data itself. It actually bloats the memory, right? But for the case of Apache PyArrow, it's not an issue. Okay, there is no duplication. So this is a simple example of it. It's not a drop-in replacement for pandas, but it's much more similar. This is a filter operation. There is a group by operation, and like the sum operation is also there. So now let's move on to the DuckDB. It's kind of a database itself, but kind of different from the conventional database because it doesn't need to be a database server. You can run it with your application. For example, if you have a fast API, you can run it with the fast API as a database. It runs in the single process itself. You could run the SQL statement directly inside it for the CSV files itself. Another great thing is the compatibility of DuckDB. You could use it with various data analytic purposes like Evidence, Streamlit, and so platforms. So some of the lessons that we learned on going to production with the data analytical pipelines is that it's always better to do chunks for using large files, especially if your RAM is much more lower, and also like avoid intermediate huge data frames, which happens when we are using the copying purposes and all, and use always caching, like even for func tools or writer tools, you could do caching, or you can store the intermediate results or Parquet files also. And of course, you need to monitor the memory usage. If you have seen closely that Alan actually Alan actually showed the memory usage of columns as well using the df.info command, right? So for every column, you can actually see how much memory it took. So and so observability things could be done. And yeah, the next thing is about the 80-20 rule, which is the 20% of the concept gives 80% of the performance. So like the vectorization, the correct data types, and chunking and all these things could be actually used to improve the performance. So yeah, this is the key takeaway of the whole session, that the pandas is pretty fast if you are using it the correctly way, and most of the time if you are feeling if it is slow, that it's because of the anti patterns that we follow for our convenience. So yeah, and even for the small changes, you can see the performance gains by 100 times or 150 times. Like their example is the vectorization. So always measure before optimizing. Always see what kind of resource it's actually consuming. So yep, that's it. Do pandas in the panda way. That's it. Any questions?
Okay, thank you for that wonderful talk. Does anyone have any questions? We are open for one question. Okay. Hmm? Okay. If you guys have any questions or you're feeling you have a question, sir? Okay.
Okay, that nice presentation. No? Just one question. We know that Pandas has been used for a standard for data frames, right? I would like to, and you have shown Polar. Do guys know of any alternative to Pandas, which try to, of course, improve on the existing Pandas, if there is a existing alternative for Pandas for data frames that you know about?
You could import data frames from pandas. Yeah, let me just. You could import the pandas data frame into polos as well. Two pandas, and from pandas, there is an option for that as well. And most of the operation that we could do inside pandas could be also done, as far as I know, could be done inside polos as well. So it's a really good. I won't say the alternative, but it's a kind of counterintuitive option. It's yeah, yeah. No, there is no total alternative. Like if you see that like the pandas itself is a very established framework. Like most of the things that we see is still dependent on pandas in a huge scale. So like there is no alternative, but like if you want some performance tweak, it's better to try with polos.